Diffraction occurs when light falls on any surface having grooves with a spacing comparable to the wavelength of the light. Diffraction of light from a compact disc surface produces colorful spectra. The shadow around the razor blade is due to the diffraction of monochromatic light. Introduction to Diffraction Grating. In this lesson, you should be able to understand the concepts used in the diffraction grating, know the diffraction pattern produced by a diffraction grating, use the formula d sine theta equals n lambda for diffraction gratings, measure the wavelength of a monochromatic light using a diffraction grating. The diffraction grating consists of a large number of equally spaced parallel slits, rulings or lines. It is a useful device for analyzing light sources. Click the Transmission Grating button. Click the Zoom button to observe the lines in the diffraction grating. Each of the slits in the diffraction grating acts as a point source emitting wavelets. Superposition of these wavelets produces a pattern known as the diffraction pattern. The diagram shows a beam of light of wavelength lambda incident on the grating and is diffracted onto a distant screen. At an angle theta to the incident direction, the path difference delta L of light from successive slits is d sine theta. Click the path difference button. Constructive interference occurs when the path difference is an integral number of wavelengths. This produces a principal maximum. Click the expression button. Light is diffracted from each of the slits. The different sets of waves from the various slits reinforce each other in certain directions only, producing constructive interference. Summary. Constructive interference occurs when the path difference in an integral number of wavelengths producing a principal maximum. Principal maxima occur when d sine theta equals m lambda, where m equals 0, 1, 2, 3 in the order of the principal maximum. A bright fringe is formed at the center of both the interference pattern and the diffraction pattern. This is due to the zero path difference between the waves arriving there. The criteria to have a maximum is the same for both the patterns. However, there is an important difference between a two-slit and a multiple-slit pattern. The maxima of the interference pattern is broader, whereas the maxima of the diffraction pattern is sharper and narrower. What happens if the number of lines per centimeter n of a diffraction grating increases? Click the graph button to understand the diffraction pattern from the intensity I graphs. Answer: the principal maxima become narrower, further apart and are of higher intensity. The diagram shows the intensity graphs of the diffraction pattern produced using blue light and red light. Click the Lines button to observe the diffraction patterns. What is the difference between the two patterns? Answer: the principal maxima for red light are spaced further apart compared to those of blue light. Click the white button to view the diffraction pattern produced when white light is used instead. Describe the diffraction pattern for white light. Answer: the central maxima is white, whereas the other principal maxima consists of spectra of colors. For each spectrum, the outer edge is red and the inner edge is violet. Explain the formation of the color spectra. Answer: white light consists of various colors of different wavelengths. Red light, which has the longest wavelength, is diffracted most. Violet light, which has the shortest wavelength, is least diffracted. The arrows marked 0 shows the straight onwards direction. Click on the 0 order in the line diffraction pattern and observe if there is any path difference between the rays from the slits to the screen. Click on the first order line in the diffraction pattern and observe that the path difference between the adjacent rays is lambda. Click on the second order line in the diffraction pattern and observe that the path difference between the adjacent rays is 2 lambda. Click the Order button to derive the expression for the maximum number of diffraction orders. The number of principal maxima is 2m plus 1, where m is the highest order of diffraction. Summary: the maxima of the two-slit interference pattern is broader than the maxima of the multiple-slit diffraction pattern. The maxima of the multiple-slit diffraction pattern is sharper than the two-slit interference pattern. As the number of lines per unit length of the diffraction grating increases, the principal maxima are further apart. The maxima of red light are spaced further apart as compared to those of the blue light. When white light is used, a spectrum of colors is formed at each maximum except the zero-order maximum.